Welcome to another lesson in our Lighting Basics series. Today we're diving into fluorescent lighting, one of the most common and widely used lighting systems in the electrical field. Whether you're training to be an electrician, a maintenance technician, or just starting your journey in the world of electronic systems, fluorescent lighting is something you almost certainly work with. So grab your notepad or just listen closely as we break it down in simple and practical terms. Before we jump into the technical stuff, let's ask a simple question. Why is this important? This topic is important because fluorescent lighting is everywhere, in offices, schools, hospitals, factories, stores, apartment buildings, and more. Even though newer technologies like LEDs are becoming more common, fluorescent lights are still in use all over the world, especially in existing buildings that haven't been upgraded yet. As someone studying electricity or lighting systems, you need to understand how these lamps work, how to troubleshoot them, and how to safely install or replace their components, particularly ballasts, which will come more deeply in the next section. Let's start with a basic definition. A fluorescent lamp is a type of gas discharge light. That means it doesn't work like an incandescent bulb, which glows because of the hot filament. Instead, it uses electricity, gas, and phosphor coating to create light. Here's how it works in 5 easy steps. First, the lamp tube. The tube is filled with a small amount of mercury vapor and an inert gas like argon. 2 is electric current. When electricity flows through the lamp, it excites the mercury vapor, which emits ultraviolet light, invisible to the human eye. 3. The phosphor coating. The inside of the glass tube is coated with phosphor, a special material that converts UV light into visible white light. 4. No filament needed. There are filaments at each end of the tube, but they are only used to start the lamp. They are not used as the main source of the light. And finally, 5, we have the ballast. The ballast is the most important part of the system. It controls the electrical current, helps the lamp start, and keeps it from drawing too much power once it's on. Think of the ballast like the brain of the fluorescent system. Without a ballast, a fluorescent lamp wouldn't even work and could even be dangerous. You'll mostly see fluorescent lighting used in office buildings, schools and universities, hospitals and medical clinics, retail stores, warehouses and workshops. Why? Because it's more efficient than incandescent lighting, long-lasting, cooler in temperature, meaning less heat output, and it's better in large indoor spaces that need even bright lighting. When you enter the electrical workforce, whether it's commercial, residential, or industrial, you're going to see fluorescent systems. And because these systems are slowly being replaced by LEDs, you may also be involved in upgrading or retrofitting old fluorescent fixtures. That means you need to know how they work, understand the parts involved, especially the ballast and tubes, be able to read specs and identify the right replacements, and know the safety rules when working with mercury-containing lamps. Let's list a few features that make fluorescent lamps different from incandescent or halogen lamps. The advantages of fluorescent lamps are that they are more efficient. They are more efficient than incandescent lamps. They use less electricity for the same amount of light. They have a longer lifespan, typically about 7,000 to 20,000 hours. They have a cooler operation, which means they give off less heat. They have good color options. They're available in warm, cool, or daylight tones. And they provide even light distribution, good for lighting large rooms evenly. Some of the disadvantages of fluorescent lightings is that they require a ballast, which adds complexity and a potential for failure. They contain mercury, which must be disposed of properly. They can flicker, especially with old magnetic ballasts. They may hum or buzz, again mostly in older systems. And finally, their performance drops in very cold temperatures, so they're not ideal for outdoor use unless the fixtures are rated for it. Here's something that a lot of beginners overlook. Always identify the type of ballast in the fixture before replacing the lamp. That's because some ballasts are designed for specific types of lamps only. Using the wrong combination can reduce lamp life, lower efficiency, or even damage the system. So reading ballast and lamps labels carefully will save you time and possibly avoid a costly mistake. And remember, fluorescent lamps contain a small amount of mercury, so always handle broken lamps carefully and dispose of them properly, following local environmental guidelines. If you are replacing a lamp, give it a few minutes to cool down, and always turn off the power at the switch or breaker before working on the light fixture. That wraps up our introduction to fluorescent lighting. You now understand how fluorescent lamps work, why they are used, and why it's important to study them. This foundational knowledge will help you feel more confident as you move on to ballast, lamp types, and real-world applications. In the next section, we'll explore the different families of fluorescent tubes and how to match them with the right ballasts. Until then, keep learning, stay safe, and light it up.